Hi students, so in this video we're going to learn about arithmetic sequences and series. And basically an arithmetic sequence is one, kind of like this one right here, 5, 9, 13, 17, 21. This is, there's a certain pattern basically for these. You've probably seen these in grade school where you try to think of what the pattern is. And for arithmetic sequences, all that's being done is you're adding a number to the first term to get the next term. And then you're adding the same number to this term to get the next term. Okay, so basically, if you add the same amount to get the next term, that's called an arithmetic sequence. And the formal definition is a sequence in which each term after the first is obtained by adding a fixed amount to the previous term. That fixed amount that we're talking about that you add is called the common difference. And here you're going to be using a formula for the nth term. Okay, so we have a sub n, meaning the nth term, and that equals the first term, that's a sub 1, times n minus 1 times the common difference. So we're going to be using this formula to find the nth term. We'll use it to find, maybe the common difference. You could find a bunch of different things using this. And we're also going to be finding the formula for the nth term. And we're going to then look at one more formula that's going to be the sum of an arithmetic series. Okay, so let's get started with this. So first of all, example 1, here is our sequence. And we can look at this sequence and say, okay, well, what's being added to each number to get the next number? You can kind of see if I add the number 4, so if I do plus 4, I get 5 plus 4 is 9. If I add another 4 to that, plus 4 again, I'm going to get 13. And so on. If I keep adding 4, I'll get the next term. And so it says here, the nth term for an arithmetic sequence, it says write a formula for the nth term. And so again, each term of the sequence after the first is 4 more than the previous term. And we can also identify the first term. So a sub 1, on this one, a sub 1 equals 5. That's the first term. The common difference is 4. Okay? And so we can actually write a formula for this nth term. So a sub n will equal a sub 1, which is 5, plus n minus 1 times 4. And so this is our formula here. We can distribute this 4 to both of these. So we'll have 5 plus 4n minus 4. You're going to distribute it. You're just going this way instead of the normal way we write it. And then we can simplify this on here. 5 minus 4 is 1. And so we have 4n plus 1. That is the nth term. And so you could use this this formula really to find any term you want. So if I wanted to find, let's say, the 10th term, you could plug in n equals 10. Okay, and so let's just say I do that. So example, if I want a sub 10, then I would plug in n equals 10, right? So 4 times 10 plus 1. So that would be 40 plus 1, which is 41. So if you kept this going out, you would find that the 10th term would be equal to 41. All right, next example in here. It says write a formula for the nth term of the arithmetic sequence. And they give us this decreasing arithmetic sequence. The previous one was increasing. Okay, so And again, remember with the sequences, we have like commas in between the terms, and then we do dot, dot, dot just to show that it continues on. So write a formula for this. So what's going on here? So if I go from 4 to 1, I'm subtracting 3. If I go from 1 to -2, I'm subtracting another 3. And I can keep doing that. I'm going to subtract 3 each time to get the next term. So if we look at this, first of all, a sub 1 is equal to the first term, that's 4. D is going to be -3 because we're subtracting 3. Okay, and then all we have to do now is write our formula again. So going back to this formula, so we do a sub n equals, and again, if we look back up here, a sub n equals the first term plus, so we're going to do the first term plus n minus 1 times the common difference, and that's -3. Okay? And so now we just simplify this, and then we'll get our formula. So a sub n equals 4, and then we're going to distribute this -3 to both of these. -3 times n is -3n. -3 times a -1 is a +3. And so now I'm going to write the -3n first, and then 4 plus 3 is 7. And again, you could use this now to find any term in this sequence. So here's another skill that you can do. Example 3. It says write the first 5 terms of the sequence, and now it gives you the formula. So here's our formula, and they just kind of put that 6 out there, just like that first one we did. But you could distribute this if you want. You could also just leave it like this if you want. I'll show you what they do in the book. They just leave it, but I'll at least show you if you were to simplify it, what it would look like. So this is equal to 3, and then if we distribute this 6, it's plus 6n minus 6. And then we've got a 6n, and 3 minus 6 is -3. So we could use this, or we could use this. It doesn't matter. But what we can do is now find the first 5 terms, like it said. So you would want to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Those are the first 5 terms. And you could, again, use the formula that we found here, or you can use the original. Okay. In your book, you'll see that they use the original, so I'll go ahead and use this then, I suppose. So on this one, we're going to just plug in a 1 for n. That's all we're going to do. So this is 6 times 1 minus 3. This is 6 times 2 minus 3. 6 times 3 minus 3. 6 times 4 minus 3. And finally 6 times 5 minus 3. If you find each of these answers, you'll get the first 5 terms. So this is 6 minus 3, which is 3. 12 minus 3, 9. 18 minus 3, 16. 24 minus 3. And we've got 30 minus 3. So if you were to, oh, what did I just do? I just realized, there's that one. I just realized that it should be a difference of 6 with each of these. So that one was supposed to be a 15. So these are the terms. So now we can write the first 5 terms. That's 3, 9, 15, 21, and 27. Okay, and again, you can see that the common difference between these is 6. And you can also see that the first term is 3, just like this thing up here. Remember, this was a sub 1, and then the common difference is 6. So here's another example that we can do. I'm going to just flip this page over. We're going to find the missing term of a sequence. So here is example 4. Find the 12th term of the arithmetic sequence whose first term is 2 and whose 5th term is 14. That's what it says in words. So we want to find the 12th term, so we're looking for that. And it says whose first term is 2, so that means a sub 1 is 2. And it says whose 5th term is 14. So that's a little bit different, okay? So what we can do, it says before finding the 12th term, we can use the information to find the missing common difference. We can actually plug these things in and try to find the common difference. Okay, so using this information, it said, so I'll write this formula down again. That usually helps. So if you think about this formula, we do have enough information to solve for D because we have the 5th term, so we know n equals 5. And then we can plug in a sub 5 is 14. So if I do this where n equals 5, okay, that means a sub 5, right, equals 14. So if I plug that in, I'll just write this on here, 14 equals. They gave us the first term was 2, so I can write 2 plus. And then again, we're talking about the 5th term here, so we know n equals 5. So we can write 5 minus 1 times d. And then notice all we have is d to solve for, which is great. So what we do is we solve, so 2 plus 4d, okay? We're going to actually solve for the common difference here. So we're going to subtract 2 from both sides. Okay, so this is 12 equal to 4d. And then if I divide both sides by 4, I get 3. So now I know my common difference is 3. And now I'm ready to do what they wanted me to do in the first place, which is get the 12th term. So sometimes you're going to have to solve for one thing first and then go back and find your answer, okay? So now let's solve for the 12th term. So again, we know now the common difference is 3. We have the first term. And if we're talking about the 12th term, that means n equals 12, okay? So we want to plug in, remember, a sub 1, so we're going to say 2 plus, and then we're going to write in parentheses, instead of n, we're going to put a 12. So 12 minus 1, and then times 3, that's the common difference that we found. And so now we can keep going and find the 12th term, which is what they want. So 2 plus, and then this is 11 times 3, which is 33. And so that means that this is 35. That's the 12th term.